To start our discussion of chemistry, we are going to review elements and atoms. Now, matter, which is anything that occupies space, is made out of elements. And in this module, you are provided a periodic table of elements. This periodic table consists of 92 naturally occurring elements, and the rest are man-made or synthesized. Now, we're not going to be concerned about all of the elements on the periodic table, but instead, we're going to streamline our focus to those elements that make up the majority of the mass of living organisms, including ourselves. Those elements are going to be carbon, hydrogen, nitrogen, and oxygen. Each element is made up of atoms, which makes the atom the elemental unit. The carbon element is made up of carbon atoms. The nitrogen element is made up of nitrogen atoms. The hydrogen atom makes up the hydrogen element, and so on and so forth. And when you look at your periodic table, you can find some information about that element and the atoms that make it up. So we're going to use carbon as an example. The carbon element and atom have a symbol of C. It's its abbreviation. And when we look at carbon on the periodic table, we can see a value for the atomic number. And for carbon, that happens to be 6. So I'm just going to write here, this is the atomic number. In addition, you will also find a value, a number, for atomic weight, or what is also referred to as atomic mass. We can use these values, this information given in the periodic table, to understand more about the elements that make up these atoms. Now, when we're talking about atoms, and that's really what we're going to focus on as we introduce chemistry in this unit, that these atoms are made up of 3 main subatomic particles. And you might be familiar with these subatomic particles. The 3 subatomic particles that we're going to focus on are the proton, the neutron, and the electron. Now, each of these subatomic particles have a particular charge that may be associated with them. Protons have a positive electrical charge. Neutrons do not have a charge associated with them, and electrons are negatively charged. Now, when we come back to these values, these numbers, the atomic number and the atomic weight that are associated with each element, this gives us some important information about the subatomic particles that are associated with each atom. For example, the number of protons is equal to the atomic number. So for carbon, we know that the carbon atom has 6 protons because its atomic number is 6. The atomic number gives the atom its identity. All carbon atoms are going to have 6 protons. If you change the number of protons, then you change the atom. So an atom with 7 protons is no longer going to be carbon, and instead is going to be nitrogen. Now, all atoms are electrically neutral, which means that the number of positively charged protons has to equal the number of negatively charged electrons. So we know that the atomic number, not by definition, is the number of protons, but the atomic number also equals the number of electrons in that atom. And I'm just going to abbreviate electrons with a lowercase e with its associated electrical charge being negative. When we think about how an atom is organized, how it's structured, we can imagine the protons and the neutrons being in the center or the core of the atom, which we call the atomic nucleus. In contrast, surrounding the atomic nucleus is where you are going to find the electrons, and we typically say that these electrons are somewhere found in this electron cloud, this space that is surrounding the atomic nucleus. So let's take what we know about the location of these subatomic particles within an atom and use carbon as an example to draw out kind of a simple structure of an atom. All right, so we know the carbon atom has 6 protons, and protons are located in the atomic nucleus, the center, the core of an atom. And we're just going to designate protons by these blue circles. Also in the atomic nucleus are the neutrons, and we're going to make neutrons red here. So 1, 2, 3, 4, 5, 6. Now in this class, our main focus is not going to be the neutron. We know a couple of things about neutrons. Neutrons are a subatomic particle. They don't carry an electrical charge. They are part of the atomic nucleus. And if we go back to one of these values on the periodic table, the atomic weight of an atom represents the number of protons plus neutrons. And so since we know the atomic weight of carbon is 12, if we subtract out the number of protons with it, which is 6, we're left with the number of neutrons, which is also 6 for carbon, and I have designated those 6 neutrons in the atomic nucleus here, but we're not going to focus on any more detail other than that for right now. All right, and then we have our electrons, which are placed out here surrounding that atomic nucleus in the electron cloud, and I'm just going to randomly distribute these 6 electrons, 1, 2, 3, 4, 5, 6, in that electron cloud. Now these atomic particles are not fixed in these particular positions that we have in our drawing. This is just a simplified representation of the general location where you would find these subatomic particles. Now I think it's important to pause here for a second and talk about the importance of these charges on these particular subatomic particles. And we're going to come back kind of to charges over and over throughout the semester. So I think it's important to review that opposite charges attract. So these negatively charged electrons out in the electron cloud are attracted to the positively charged protons in the atomic nucleus, and that's what keeps these electrons associated with this particular carbon atom. Now, although like charges do attract, we also know the flip side of that as like charges repel one another. And like I said, those concepts will come back to us as we move throughout chemistry and our biological molecules. So before we end this video, let's review what we know about atoms by using the oxygen atom as an example. If you look up the oxygen atom on your periodic table, you will notice that it has an atomic number of 8. So we know that the oxygen atom has 8 protons, and I'm just going to abbreviate protons with a lowercase p and a positive symbol to represent its electrical charge. We know all atoms are neutral, which means that an atom will have the same number of protons as it does electrons. So oxygen has 8 electrons. And then from the atomic weight, we can also determine that oxygen has 8 neutrons. Now, I'm not going to draw the individual circles out as we kind of draw the structure and organization of our atom, but I'm just going to place 8 protons in the atomic nucleus. They are going to be in the atomic nucleus with those 8 neutrons, and then within the electron cloud that surrounds that atomic nucleus, there are going to be 8 electrons. Now, we talked about the differences in charge and location of these 3 subatomic particles, but we can also talk about differences in their mass. Now, the protons and neutrons that are in the atomic nucleus, they have a size, a mass of 1 Dalton. And a Dalton is a unit of measurement used in the metric system. So each of these, both protons and neutrons, they have a general size of 1 Dalton. So they're roughly equal in their size. In contrast, electrons that are found out here in the electron cloud have a size of about 1/2000th of a Dalton. So these electrons are very small in comparison to the protons and the neutrons. Well, I hope this review of atoms and elements has given us a good foundation to start our discussion on chemistry.